So this is some fan art. We have apparently a big fan community in Japan, and they make these comic books. And so this is one of the covers. I don't know. I don't speak Japanese, so I don't know what they're saying about Deno in those books. But the cover is just awesome. I wanted to share this with you. Something else I wanted to share with you. This is a very terrible picture. 7 years ago, I did my first and only previous talk on dotJS. So that was in 2012. And I took a picture for my mom so she would believe that I actually had been on stage and there was a huge crowd. As you can see, phone cameras were not very good in 2012. So if you don't mind, I'm going to redo it real quick, and we'll see in another 7 years how it turns out. And in 2012, I was talking about all the virtues of Node.js 0.10, I believe. But that's not today. Today, I'm going to talk about what is going to destroy Node. But first, a little bit of background. So this here's Ryan Dahl. You probably have seen his picture. Quite blurry. And by the end of 2017, Ryan and I worked on Node.js a long time ago, starting for me 2010 or something until 2013 when he kind of quit the project. But at the end of 2017, we kind of got together again and we decided to both quit our jobs and try to build a machine learning framework for JavaScript. We just got a talk basically about TensorFlow.js that didn't exist at the time. And we were like, no, we hate Python, but we want to use TensorFlow, so we are going to do this. The framework was called Propel. But sure enough, half a year later, Google comes around and they steal our thunder with TensorFlow.js. And we're not very smart, so we couldn't compete with that. But what we had learned in the process is that it's actually, using Node.js has become, arduous, especially if you want to build like a complicated framework. We just got the itch. We wanted to make something to make using Node.js nice again. So I'm going to talk about what is going to replace it. First, a quick word of warning, though. This Deno thing is very much under development. When I talked in 2012 about Node.js, it was 3 years old. Deno is not even a year and a half. So, if you design airplanes, don't put Deno in it yet, especially if there's MCAS and stuff. There's probably many bugs, but we'll work them out. And this is just an early preview. So just in case you didn't know, Deno is a new runtime for JavaScript and also for TypeScript. We really love TypeScript, especially if you're building libraries. It just takes away so much of like the asserts and the tests you have to do. And we also want it to be a good runtime for WebAssembly, although WebAssembly is a complicated thing because in itself, WebAssembly needs to come from somewhere, right? So I'm not going to make any claims about that yet. It's built on top of V8, just like Node.js, but then things are different. It's built on top of Rust. Rust is, you might have heard about it, is the cool new thing, and it is hard to use, but once you master it, it makes it a lot easier to build fast, integrated, compiled software. It's built on top of Tokyo, so I've spent a lot of my years working on libuv. That's out of the door. We just use a library that already exists, and that's one of the really nice things about using Rust. You have these libraries, and it has TypeScript built in. So if you ever use TypeScript nowadays, you will probably be using TSC if you just want to use it standalone, or TS Node if you do it with Node, or most likely you have some build setup with React with Webpack or Parcel, any of those things. We don't like any of that. We wanted to have it built in. And that's exactly the reason why we want to make Deno in the first place. Node.js, it is good, but the world and especially the JavaScript ecosystem has progressed quite a bit since it was first designed in 2009. So nowadays, for example, we have promises and async functions. So why do all these Node.js APIs still use callbacks? We have async iterators and generators. But in Node.js, you have the streams and then streams 2 and streams 2.5 or 3 or whatever. We have Node.js has a module system that worked, but clearly the future of module systems is ECMAScript modules. Node has buffers, and the world nowadays and the browser has typed arrays. So the JavaScript language has moved on. And then Node in itself has some problems too. In particular, we do not like its module system. We don't like that NPM is centralized. We don't like that most likely when you install a module, you will get hundreds or thousands of files, which are actually mostly not used when you run your program. We do not like that Node.js has no security model. So, in the browser, we are used to running JavaScript in a sandbox, and nothing can really go wrong. But in Node.js, you have to basically just trust whatever code you download. And as I already mentioned, nowadays, building a modern Node.js application usually involves like an explosion of tools like Grunt, Go, Webpack, Babel, Parcel, TypeScript, JS, etc., and probably ESLint, what have you. And so that, of course, they all serve their purpose. I'm not saying that these are bad tools, but it's not very practical that you have to kind of figure out all of them and make them work together in order to develop an application. So Deno is the opposite. Deno is a single executable. It has TypeScript built in as a first-class language. It does imports. It uses modern ECMAScript import syntax, and you can pull modules directly from the web, and that's the only thing it does. As much as we can, we make APIs web standard. So fetch, crypto with get random bytes, whatever on it, blobs, text encoder, and then inside the executable, we build in all the tools. We can do bundle for you, so you don't need parcel. We can do formatting, so you don't need prettier. Testing is built in. You can install utility scripts like npm install. You don't need a separate package manager. We'll add even more stuff later on, like generating documentation, building a self-contained executable, so the runtime and the code all built into one file. So you can distribute it in App Store, for example. That is our goal with Deno. Well, we're obviously not completely there yet. It's only a year and a half old. But, we have something. This is what we have built in already. So bundle, eval, test. We can run the test that you define in your code. And I want to show you a little bit of a Deno program. So this is hosted on our website. It's just a very simple example, a file that uploads a program that uploads files to js.github.com. As you can see, it is simply put at a URL. And we show it here with nice colors, etc., because our server sniffs out that you're actually visiting it from a browser, and so we colorize it for you. If you would curl this URL, you would just get plain text. And we also import a URL here, or import another module here, and that simply comes from another URL. No shenanigans, no npm install. So let's see if this works, actually. Yeah, I want to upload a file to JS, so let's check that I actually have a file to upload. And let's see that we can actually run directly a program that's hosted at this URL. Now, I told you Deno has a built-in security model, so it's going to complain to us, hey, we need to give it access to the environment. So we try it again, and we give it the permissions it actually needs. And if we're lucky, this is actually going to work. And yes, there we go. So this is, if you can copy this really quickly to your laptop, you can see that actually this file got uploaded. Now, of course, as you can see, this is a very, it's kind of tedious to type all this stuff in, especially if you need to run something over and over again. So that's why we have Deno install. We can say, I want a command that's called gist. The gist comes from this URL. It needs these permissions. And, well, there we go. It installs it for you. And if we try it again, we don't have to type give it the permissions again, then yes, there we go. It can simply, so we basically just quickly installed a tool that was on a website. And well, I took a screenshot after recording this, so just to prove that it actually works. Just because we really want to, bring the way you write server-side JavaScript and front-end JavaScript closer together, that means that you can also use some of the built-in tooling that we have in Deno for front-end JavaScript. So, for example, this is a simple website, a simple example website that actually uses ECMAScript modules. And so what we will see is that if we get the main entry point, which is bootstrap.mjs, and we type Deno info, and we ask it for some information about the URL, that it will indeed just pull it down. It will tell you like a nice module, how the module structure is built up. We could, in theory, do Deno bundle, for example, and that would just work. But I don't have the time to show all that stuff. Now, there's one thing more that I need to tackle about, or tell you about Deno. It's written in Rust. So why is that really so special? Well, one of the big issues with C++, which is what Node.js is written in, is that you have basically two options. You write everything yourself. So this is, how Chrome is developed. Google writes everything, and then they figure out a way to glue it all together. But if you are just two open source maintainers, then you don't have time for that. And that means that you are going to use other people's libraries and spend basically all your time on maintaining the build system. Because in C++, nothing ever works together. And this project uses CMake, and V8 uses nowadays GN, which you probably have never heard of. And then there's VCPKG, et cetera, et cetera. And that makes it very, very tedious to build on the shoulders of giants, as they used to say in science. In Rust, this kind of has been figured out. You can just, kind of like NPM, add a so-called crate, and you get all this functionality, which is why we didn't have to write libuv, because something like libuv already existed, and we can just jam it in there. Why we don't have to write an HTTP parser, because HTTP parsers for Rust exist. And there's another advantage to it, which is Deno itself can be a crate. With Node.js, of course, Node.js is a very useful tool, but sometimes you want to run V8 or V8 plus some extra features inside a different context. A very well-known one for that is Electron, for example. Building Electron is actually quite complicated. But it's not just Electron where you might want to do that. For example, if you want to build functions as a service cloud runtime, think Amazon Lambda or Cloudflare Workers or what have you. If you want to put V8 in there, then you're going to have to do a whole lot of work. You can imagine a database where you have stored procedures that are written in JavaScript. You can imagine game engines that you can script with JavaScript, or office productivity tools with a macro language which is based on JavaScript. All that stuff nowadays requires that you basically figure out everything yourself. Building Node.js is really hard. And so we're building Deno in a way where you can basically pick little components of it and put it where you need it. So you can think of, I'm going to put Deno in my database, but I don't need access to the file system. That makes no sense. The only thing I need is, basic JavaScript execution and, access over, a local socket, for example. It's just an example, but we really want to make it easy so you can get creative. And so we are starting to do this. The final breakdown in modules is really not there yet. But as you can see, we have 10 modules published, and 8 of those or so are actually part of the current version of Deno. And these little pieces can help you if you want to put a JavaScript engine inside something else. Okay, I told you Deno is not done by any means, but you can download it, and I would really encourage you to do it. We were hoping to release 1.0 by the end of the year. Now, the end of the year is really close, so I'm going to say January, okay? If you don't mind. And 10 is also just a number, but it signifies something, which is that we want to kind of cut back a little bit on like the rate of change and breaking APIs so much, and et cetera, et cetera. So what are we trying to put in there? Well, we want to improve WASM support a little bit. So basically, we can tell you, like, oh, if you want to use WebAssembly, this is how you build it, this is how you import it, et cetera, et cetera. It works to some extent right now, but the story is not end-to-end complete. I told you about breaking up Deno in different crates. Basically, we want to break every single binding, and a binding is like, file open, fetch, I don't know, anything. We will want to put all of them in separate crates so that you can really decide which ones you want and which ones you don't want. There's a few more things. Web crypto needs to be completed. Documentation needs to be improved. We're working on a better Rust binding for V8. And I don't really have too much time, by the way, to go over all this. Let's talk. If you want to contribute to it, let's talk after the break. Deno is really an open collaboration. So these are our top contributors right now. Your name could be up on this list. Basically the top row is the people that are super active, but there's a lot of people that are sometimes around. But this is not a project that is saturated where there's a lot of drama and committees yet. So if you have time on your hands, please look into it and see if there's something fun you can do. And this is where you get all the information about it. Oh yeah, and I wanted to show you this picture again. This is Deno Book 2 that they made in Japan. Thank you very much for your time.